Good evening once again from Jodrell Bank in Cheshire. Tonight we continue the big countdown to the astronomical event of the decade here in the UK.
Yes, tomorrow morning every single one of you has the chance to witness a spectacular solar eclipse, and we'll bring it to you live. Everything you need to know coming up later tonight.
Plus the one and only Buzz Aldrin Apollo astronaut is still with us again, as well as Dr. Matt Taylor, who last year landed a craft the size of a washing machine on a comet. He'll be telling us all the latest news from Rosetta, including whether that lander is dead or alive.
I'm Brian Cox, he's Dara O'Brien, and this is Stargazing Live. Well, what a week it's been. You know, I was looking at Twitter and people were accusing me of giggling when I spoke to Buzz Aldrin. Of course I giggled when I spoke to Buzz Aldrin, especially when he said that he launched himself off the moon with a felt-tip pen.
I was accused of just being fanboying, essentially. Yes. I was just reaching over and touching him on the leg every so often. Last night we asked for your help to find new exploding stars, supernova. We've had 500,000 hits already, and the breaking news is we think we found one.
Yeah, look at this, is exciting. So this is an image, one of the images that you went through. So this is a distant galaxy. And this here, you can see, is a bright explosion that wasn't there in this image, and that's the subtraction of the two. This, we thought, was a supernova, so we turned one of our telescopes. We rang up Chile, as Chris Lintott does, turned this telescope towards it, and confirmed it is a supernova, so you found one. And we'll give you the details of it later in the show, but it's terrifically exciting. That's something that happened a long time ago, and we captured the light last night, and you saw it'll be gone in a week.
Of course. Now, we'll also be talking about the eclipse a lot, including you giving you a guide of how to watch it safely. But first, some stargazing a little closer to home. We've got Dr. Lucy Green outside in our dark field with clear skies, would you like to say. What are you and your astronomers hoping to see tonight, Lucy?
We have clear skies, that's right. And I'm joined this evening by Macclesfield Astronomical Society. Give us a cheer, guys. Hey, you can feel the enthusiasm because we are enjoying a fantastic view of Jupiter. Now, have a look at this. Here is Jupiter with its 4 moons, those white spots there in the image. And at the moment, 3 moons are on one side of the planet and 1 moon, Io, is on the other side. Now, last night, the situation was different. All the moons were on the right-hand side of the planet. And it's this enchanting dance these moons are making along a straight line that's making Jupiter so special at the moment. It only happens every 6 years, and I will be showing you more later on.
Thanks, Lucy. And as ever, don't forget, if you've taken any pictures of Jupiter's moons or any other highlights of the night sky, please send them and your questions to us. The address is on your screen now. But the big countdown is there are now just 12 hours and 15 minutes before the moon takes its first bite from the sun in tomorrow's nationwide solar eclipse. That first contact will be at 8:18 in the morning in Penzance. It will occur a little bit later around the country in Cardiff at 8:22. You see the times there for London, Birmingham, Belfast, and then further north, the later it is, Edinburgh at 8:30. But as for the maximum, where you'll see that perfect smile, that will be at 9:28 in Cardiff, 9:30 in London, and then you see the times again latest Edinburgh at 9:35, where they'll see 93%. So the show is about a 2-hour show of the moon passing in front of the sun.
You should present the weather. You did that just like a weather presenter. There's a career for you, I think. All over the UK, the moon's going to cover the sun. Up to 98% if you're in the north of Scotland. But we're looking for a total eclipse. So here is what we hope to see. That's what Liz is going to see because she's gone up north 200 miles into the Atlantic to the Faroe Islands.
So last night, Liz left for that total eclipse in the Faroe Islands, and the great news is she's made it there. How are preparations going, Liz?
Not too badly, Dara. We did make it. The weather is horrendous. I'm really glad Lucy has clear skies where you are. But yes, I'm in the little harbour of a fishing village called Aya on the northwest of the islands. And all day preparations have been underway. Up on the hillside behind me in the school, which they're transforming into an eclipse viewing station for hundreds of eclipse watchers tomorrow morning. But there's one question on everybody's lips. Where will we go in the morning to get the best view? People are spreading throughout the islands. They're heading out to sea to try and get clear skies. We're taking it a step further, of course. A bit more about that later on. But there is a real buzz about the place here, and the islands are enjoying an astonishing transformation. The remote Faroes are only a few degrees south of the Arctic Circle, but that hasn't stopped cruise ships and boats bringing eclipse hunters here from all over the world. There's not a hotel room or hire car to spare. The Faroes are about 40 miles across with a population of about 50,000 people, but now an estimated 8,000 extra people have crammed onto the islands, all hoping to catch a view of the total solar eclipse. Now, there is still some uncertainty about the weather, and right now it is still raining. But one thing we can be sure of is that at exactly 09:40 and 57 seconds tomorrow morning, the shadow of the moon is going to pass across the sun and cover it completely. You might wonder how we can be so sure about the time, but the truth is astronomers have been able to predict eclipses for quite some time now. There have even been records found in the Middle East and in China dating as far back as 2500 BC of eclipses. And in fact, one theory even suggests that one historical site closer to home was used to predict eclipses. It's one of the world's most iconic sites. But despite years of archaeological study, it's still shrouded in mystery. No one really knows why these stones were heaved into position here. This place was used as a cemetery at one point and possibly a ceremonial site to celebrate the changing of the seasons. But beyond these massive stones is a lesser-known feature that some people believe was dug to mark the movement of the sun and moon across the sky.
Okay, you imagine this originally is about 6 feet below where we are now.
Simon Banton is an archaeoastronomer who studies how ancient humans observe the skies. He thinks that the architects of Stonehenge may have had eclipse predictions in mind when they constructed one of the early parts of the monument 5,000 years ago.
These are the Aubrey holes, a ring of evenly spaced pits, about 1 metre wide and about 1 metre deep, and they run around the monument just inside the bank and the ditch.
And what is it about the holes that suggests they might be useful in predicting eclipses?
It's the number of them. There's 56, and that's a really useful number if you want to represent the cycles of the moon and the sun.
The Aubrey holes are now filled in, so we've come to a spot away from the main stone circle. We're going to take a look at how this series of pits could have been used by ancient Britons as an astronomical calendar.
We need something to represent the sun and the moon, so we're going to do that with coloured balls. We've got a blue one and an orange one. So if you be the sun and I'll be the moon, or I'll give you the nod when it's time to move the sun, okay? 1, 2.
So is this circle a giant clock, with the sun and the moon as its hands? The theory is ancient astronomers would move the hands around the clock to show how the sun and the moon move around the sky. Each day, they'd move the moon marker by 2 holes.
1, 2.
So it completed a circle in 1 lunar month. They'd move the sun marker more slowly, taking a whole year to get around. Once a month, the moon would lap the sun and land in the same pit. Look at that! And that told them a new moon was due. But to predict eclipses, they needed a third hand on their clock. This one would have marked the times when they observed the moon at exactly the same height in the sky as the sun. They would have noticed this happening twice each month and marked those times on opposite sides of the clock. The final piece of the jigsaw was realizing an eclipse could only happen when all 3 markers landed in the same pit.
1, 2.
When a new moon would occur at the same height as the sun.
And you move the sun again.
Look at that.
So what we've got is the moon and the sun in the same hole, and they're in the same hole as a crossing point, so we've got a solar eclipse.
The system isn't perfect, but if the theory is right, it would be an amazing example of ancient man's desire to understand the skies and Earth's place in them. We may never know what the exact purpose of the Aubrey holes was, but it is an exciting notion to think of a giant Neolithic computer with which our ancestors aligned their markers and marvelled at the eclipse that followed. These days, of course, astronomers have technology and a far more sophisticated understanding of our solar system on their side. Take a look at this. This book catalogues every eclipse as far back as 1501 to 2500, and every event is detailed with extreme precision. Now, earlier on today, as we were whizzing our way to Aya, we got the chance to meet the man behind the book. He's probably the world's best-known authority on eclipses, and actually for 37 years, I should say, he was NASA's own eclipse expert, Fred Espenak. Fred, how many eclipses have you seen to date?
Well, I've been to 26 total eclipses, and I've seen about 3/4 of them.
And you're still not tired of them?
Absolutely not.
What first got you into them?
Well, I was a student, and I knew there was a total eclipse passing through the east coast of the U.S. where I was living, and I thought it was my one chance in a lifetime to see a total eclipse. So I got down into the eclipse path, saw it, And immediately after the eclipse was over, I knew I had to see another one.
And I'm presuming you're planning a whole lot more in the future.
Absolutely.
Thanks, in no small part, to this book that you are responsible for compiling. How complicated is it to get all this precise information for each and every event?
Well, it's a lot of mathematics. You have to understand and be able to predict the exact positions of the Earth, Moon, and Sun in space. And then you've got to be able to project the shape of the moon's shadow across the sphere of the Earth, which isn't even a sphere. It's an oblate spheroid. So all this stuff has to factor into it.
Is it all computerized? Once you've done a couple now, the computers are doing the work for you, giving you all this incredible data?
Yes. Yeah, I mean, to do the calculations, once the eclipse program is ready, it might only take seconds to do the calculation. It might take me years to tweak the program and get it just right.
You really are the eclipse expert, aren't you? Depending on where we are on the Faroes, there are different, exact predictions, but we're getting 9:40:57 exactly. That's when the total eclipse will happen. How can we be so precise, and can we actually be precise to the second?
We can. We know exactly the geometry of that stuff, and you can calculate it probably to a fraction of a second.
Yeah. Well, thank you so much for taking the time. I know you're giving lots of talks. You're a very busy man for tomorrow morning, but we appreciate you taking the time. Pleasure to meet you. Real honour.
Thank you.
The wonderful Fred Espenak there addressing hundreds of eclipse chasers tonight in preparation for tomorrow's spectacular display of celestial mechanics. Join me later. I'll be telling you about our very own eclipse chasing mission. See you in a bit.
Now, we keep stressing how important it is that nobody looks directly at the sun at any time during this eclipse, and this is not just some health and safety obligation.
I just say that. You usually hear that, don't you? But in this case, it is genuinely dangerous, so you need to be careful.
The best thing to do is get yourself some of these, but actually these are possibly rarer than an eclipse at the moment. These are the only two glasses we actually even have here ourselves.
But these will be on eBay after the show.
Yeah, after the show.
500 quid each.
Oh, yeah, by like 12 o'clock tomorrow, they're yours. But the question everyone's asking is, how can I enjoy it if you haven't got these? And by the way, one thing that's worth noting is sunglasses are no substitute for these. Welding goggles, somebody asked me on Twitter, are no substitute for these. These have a special, safety mark. We know that these are strong enough. If there's a scratch on them or hold them, they're also not going to work. So err on the side of caution as much as you can.
Best way to do it, of course, is a pinhole camera.
Right. Now, this is very, very straightforward. Just a piece of card with a pin inside it. Now, let's use this light here. Let's get into this light. So this is substituting for the... now, can you see that? That will give you a very clear impression of...
That's literally what you do. And just to show you that it works, if I move the moon in...
There we go.
There
you
you
can
see.
see your eclipse. So you said so, and you can obviously make a version of this with a box, with a shoe box, for example, or any other box. You can punch a hole in it, and you'll see the sun, and actually you'll get a nice, steady image of it as the moon as it crosses in front of the sun.
Yeah, but that's actually good enough. And this is the safest way. I think particularly if you've got young children, you don't quite trust them with the eclipse goggles if you've got them, then I think this is a beautiful way of seeing it, actually.
We keep saying the word colander, by the way, and people have asked, is this really a way of doing it? The colander, obviously, let me see if I can focus it a little bit there. The colander will create a kind of a collage of solar images, and then if we start it, look, you can see the moon passing in front of you. You can see, wait, have you got it? There we go.
There it is,
Look
there
at
it is.
That. That's incredible. That is how the eclipse will look to a fly.
It's not really incredible, is it?
No. Right.
Do it with the paper.
Yes, that's
Far
an
simpler.
easy thing in the world too. Just 2 pieces of cards, that's all you need. Now, if you go to our website, all the information you need to make these and guarantee you get the best out of tomorrow's eclipse is there. One interesting thing is the fact that we know precisely when the eclipse is going to happen. This is all down to the very first laws of nature, which were introduced by Isaac Newton back in 1687.
I was going to write them down on here and I've forgotten. F equals MA and F equals GMM over R squared. That's
Teacher,
it.
you turned out to be.
But it's very beautiful.
It is
Because
very
that's what
ridiculously
you
simple.
predict the eclipse.
Yes, absolutely. And it's these same laws of nature that also allow us to predict the path to the moon, which is a handy link to welcome back Apollo 11 astronaut Buzz Aldrin.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Buzz, we were talking to you about arriving at the moon yesterday. We got a question from Alistair Devlin who asked, how difficult was it to rendezvous the lunar module that you and Commander Armstrong were in with the command module after leaving the moon? How difficult was that maneuver?
Well, everything is done according to time. And back in Mission Control, they have a very precise orbit of Michael Collins in the Columbia. So they can compute the exact liftoff time. We couldn't do that.
Yeah, so you're just strapped in at that point.
So we lift off and start heading in the right direction. And then there are 2 maneuvers.
We can actually see them here. Sped up now.
Well, this is close. This is coming into dock. This is after the spacecraft has come very close. And right up here is where the docking cone is that'll fit into the
Oh, I
command
see.
module.
So you aim for this.
Oh, this
That's
is the
target.
radar, but this is the docking cone.
I see. So you said there are 2 maneuvers, so they're pre-programmed, pre-calculated in by time. So they say at 10, 24 and 43 seconds you fire the engine.
Yes, but they can be changed depending on the orbit and what kind of orbit we get into right after liftoff. And their purpose is to provide the right conditions for the second maneuver, which will put us in an orbit that catches up with Columbia.
And how fast are you catching Columbia before you dock?
Oh, maybe 100 miles an hour, 200 miles an hour.
Really? So not extremely fast?
No,
fast
no.
enough.
We're just gradually catching up, and we get to the right point, then we initiate the transfer, the intercept, and that may take about 120 degrees.
How did it feel when you saw Mike Collins again? What was the first thing he said to you when you opened the hatch? Because he'd, of course, been orbiting around the moon sooner. Well, no, about a day, wasn't it? Were you down for... It was only a few hours, actually. You were down on the lunar surface, wasn't it?
No, we were touchdown to liftoff was 20 hours.
20 hours. So what did he say when you opened the hatch? It was just like, you lucky...
Where you guys been?
That's what he said. And how was that? Because then immediately you're on your way back to
No,
Earth
he
again.
said, you guys are awful dirty looking.
Did he?
Yeah, he had a vacuum cleaner, which is part of the suit.
Oh, right, because the dust just got in everywhere, didn't it? There's photographs of all over the suit.
Some of the later crews got really dusty because, they were clumsy. They fell down. But we were very careful. We didn't do that.
And elegant.
We weren't out very long.
How was it as a crew? Because then you've got your journey back. So did NASA fill your time on the way back to Earth? Or are you kind of just, like, that's it, we've done our job?
Well, we listened to music and watched the moon. We came by the backside of the moon as we left, and we went away. And there's a beautiful crater on the backside that you can't see from Earth, but it's Tsiolkovsky. It's a dark interior inside the crater, and there are two big peaks that stand up. It's probably the most characteristic, beautiful sight, if you can call a pile of dirt beautiful.
Was it emotional to leave the moon, to see the moon receding behind you?
I'm not sure that fighter pilots really have those kind of teary emotions. Of course, everything that transpired in that whole mission was only going to happen once. Yeah. And for the rest of our lives, we look back and remember that great opportunity that came our way.
Fantastic. And a series of beautifully intersecting curves, and it all worked out fantastically. I mean, if we've managed to work out all the complexities of getting men to the moon, you'd think we'd be answered definitively the age-old question of how many planets there are in the solar system. But we really can't.
From here on Earth, we can see 5 planets with the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. So if you count the Earth, that's 6 planets that have always been known. Then, in the early 1600s, the telescope was invented, and by the 18th century, we'd found Uranus. So now there were 7 planets, but there was something a little bit strange or unusual about the orbits of Uranus. So the other 6 planets move almost precisely in accord with the predictions of Newton's law of gravitation. Uranus doesn't quite do that. So there are only 2 options. One is that Newton's law of gravitation is wrong. It is slightly, but not that much. Or there's something else out there which is affecting the orbit of Uranus. It turned out to be the strong gravitational pull of a massive unseen planet, an ice giant. Planet 8 became known as Neptune. Believing Neptune couldn't account for Uranus's strange orbit on its own, wrongly as it turned out, they carried on searching. And in 1930, Pluto was found. The set of 9 planets was complete. Or so we thought. 2 researchers in America suspected that Pluto wasn't alone. In 1992, after a 5-year search, they discovered Pluto was merely one of thousands of huge icy rocks orbiting in a band around the solar system. They discovered the Kuiper Belt, and our 9th planet was suddenly in jeopardy.
We knew that that was the end of Pluto, but we discussed that at the telescope. We said, well, Pluto's finished because, now it's just another object out there.
When a 10th so-called planet, Eris, was also found in the Kuiper Belt, it made scientists question what a planet really was. This is what they came up with. Firstly, a planet has to be spherical, which is essentially a requirement that it has to be massive. So any sufficiently massive ball of matter will form itself into a sphere. Secondly, it has to be in orbit around the sun. That means moons, for example, which orbit around another planet, are not counted. And thirdly, and this is perhaps the most subtle, but very importantly, they must be gravitationally dominant. That means that they must clear everything else out in their orbit around the sun. So Earth, Mars, Jupiter, Saturn all satisfy that requirement, but Pluto and Eris don't. Pluto and Eris are just part of the crowded Kuiper belt, which means we're back to 8 planets. But is 8 the final answer?
Here we've got the Sun in the centre of the solar system. Around the Sun, orbiting at a distance of 93 million miles, is our planet, the Earth. The outermost planet at the moment is Neptune. So far out, it takes almost 200 years to go once around the Sun. Beyond Neptune, we've got the Kuiper belt.
Our planets and the Kuiper belt objects follow a similar pattern around the Sun.
So it was a bit of a surprise when a few years ago, an object was discovered way out here, Sedna. And Sedna's orbit is amazing. That takes it over 1,000 times, almost 1,000 times, the distance of the Sun from the Earth. And it's not the only one. There's another guy that comes like this, and there's another one that goes...
So what's the reason for these unusual orbits? Alan Fitzsimmons believes the number of planets in our solar system is not yet decided.
It could be that there's another planet out here guiding these objects by its gravity.
Is it possible that there's at least one more planet in our solar system lying undiscovered in the dark?
Well, if we learned nothing else, we learned that Alan Fitzsimmons draws really good circles freehand. That would take about 8 takes for me to do that. In July of this year, Pluto is due to be visited by a mission called New Horizons. It actually set up 9 years ago, before Pluto was demoted from being the 9th planet. It's the only one of the original 9 we haven't yet visited, and we know very little about it.
We do. This is the best image we have of Pluto so far, and it's from the Hubble Space Telescope. So that's the best we can do from ground-based and space-based telescopes on Earth. And you see images like this. What's interesting about this image is you see Pluto's moon, Charon, and whilst New Horizons was on its way, this is the New Horizons spacecraft, by the way, during the flight, we discovered 3 more moons. And there was some concern because the trajectory of the spacecraft had been planned without any knowledge of these objects. And they've turned up now. It's not going to hit them, but that's in a sense coincidental. There may have been a course correction necessary.
So is there any way we can make estimations of what Pluto might be like?
We can. As you saw in the film there, Pluto and Charon are Kuiper belt objects. There are potentially 100,000 objects of a reasonable size, about 100 kilometres or more, out there to be discovered. But some of them are in the inner solar system. Some of them, well, not the inner solar system, but orbiting around planets in the solar system. One of them is Triton.
By the way, for every Triton, we've discovered 4 moons, by the way, 4 extra moons. I know they did.
4 extra moons.
4 extra moons. We're up to 5.
Only 3 of them on here. So we've got a movie which was made from the only images we have of Triton, which was taken by Voyager 2.
Right.
So Voyager 2 passed by through the Neptune system, and it took these images. So this is an interesting world. It's most likely an object that was in the Kuiper belt and was captured by Neptune's gravity. So this may be what Pluto looks like. And it's interesting because if I show you this picture, this is a picture, again, taken by Voyager 2. You see that we thought that these are worlds that are frozen solid, minus 225 degrees Celsius. So no one expected them to be active. But if there's anything we've learned about moons in the solar system, they always surprise us. So this is a Voyager 2 image, and you see there are these dark smudges on the surface, which are interpreted as plumes of material outgassing from the surface, and those cryovolcanoes. So there's volcanism of a kind, even on Triton.
So they're much more active than we would have, than they've any good reason to be.
Yeah, and so one of the big questions on Pluto when we get there is, could it be active enough to support a liquid water lakes or ocean beneath the surface? In the same way that if you look up at Jupiter tonight, actually, one of those points of light is Europa, a moon with more liquid water than all the oceans of the Earth combined. There may be an ocean beneath the surface of Pluto. Some scientists suspect that. We don't know. But then you even start asking questions about potential microbial life out on these. We ask those questions about the moons, so why not about these Kuiper belt objects? Now, remind you, hundreds of thousands of them waiting to be discovered.
OK. Now, we may have found that Pluto has 5 moons. That's nothing compared to Jupiter, which is a total of 67. And right now, Lucy's looking for its largest 4.
And here are those 4 moons orbiting around Jupiter, which we can see in the southern sky at the moment. Now, actually, what we're interested in is the pattern that those 4 moons take on, and indeed how that pattern changes from night to night as the moons dance around their parent planet. Now, it's interesting at the moment because Jupiter is in equinox season. So what does that mean? Well, the moons are orbiting around Jupiter's equator, and that's tilted. And it's almost as if the moons are rolling around the edge of a giant tilted cosmic plate. And if you look at that plate face on, you see the moons going up and down and side to side, tracing out ovals in the night sky. But during equinox season, we're looking at the plate edge on, so that the moons are just moving along a line. And that means that at the moment it's a great time to go out and see these moons eclipsing each other, casting shadows on Jupiter. And for amateur astronomers, you can get some amazing images and also time-lapse videos of this dance playing out. And indeed, our cameraman Mark popped out and caught some of this in action a few weeks ago. Now, over the last few nights here, we've been lucky enough to see this dance playing out. So on Tuesday night, when we looked at Jupiter, we had 2 moons on either side of the planet. But it didn't stay that way for long. Last night when we looked, we had all 4 moons on the right-hand side of Jupiter. And in fact, we even caught the 2 innermost moons changing places. Now tonight when we look, Io has gone all the way to the other side of Jupiter, leaving those more slowly moving moons, Europa, Callisto and Ganymede behind. So we will be coming back tomorrow to see how the moons ends the week. And it might not be what you expect.
Last November, the world held its breath for one of the greatest achievements in the history of European space exploration, all space exploration, I think. A space probe called Rosetta arrived at a distant comet called 67P, and its landing craft Philae, brave little Philae, managed the first ever successful touchdown on the surface of a comet.
You can't say their name, can you, without saying something like that?
I've just personalised Philae so much. I know, look at him, he's so sweet. We're delighted to welcome the star, and brave, the project scientist for the Rosetta mission, Dr. Matt Taylor from the European Space Agency. This was the end of an enormously long journey, though.
Yes, it was. It took us 10 years just to get to the comet, just to get ready to do all of this science that we put it up there for in the first place.
And not even in a straight line. This is 10 years of an incredibly complex path you took.
Yeah, it's a big spacecraft. It had about 3 tons launch mass. That 60% of that was fuel, but you still haven't got enough energy to get out to the orbit where the comet is. So we had to use the gravitational acceleration of the Earth and Mars. We went past Earth 3 times and Mars to kick us out to get this orbit right out to where the comet is and chase it down in 10 years.
Yeah, and then when you got to the comet, there's a lot of manoeuvring went on to get into orbit around this tiny object. You didn't know much about the object.
No, this time last year we still didn't know it was this duck shape, and so your operations are such that you're basically stepping towards it gradually, and these legs are there to start feeling out what the gravity's like.
So that you can work out how to fire the engine.
How to ride the bike around the comet, yeah.
And after that ludicrous journey, of course, then there's the big day on the 12th of November. They were all watching that slowly occur when Philae was detached and dropped onto
Lovely little Philae.
Lovely little Philae.
Yeah. This is from about 23 kilometres from the comet. It was pretty good shooting from the flight dynamics people. We got within about 120 metres of where we targeted for the first landing.
Yes.
I think we've got some real images of
this is
what you thought it would look like, but this is
actually, this is what happened. This is from the Osiris camera and a collage.
So these are real photographs?
This is as it's approaching, from the orbiter.
That's
and then you see the differences before and after to show that there was an imprint. We left our mark at least where we were supposed to land.
Oh, so those are 3 legs?
Yeah, we think they're, there's some discussion as to what that's telling us, but roughly around that spot is where we hit first.
And how high did you bounce?
We think about 150 metres, basically, something like that. This is the thing, this comet has a very low density. It weighs about 10 billion tonnes, but its density something like styrofoam or cork, polystyrene in European, I guess. And so we had to try and affix ourselves to that. If you were on Earth and you could jump higher than 4 centimetres, you can leave this comet. That's the escape velocity. So it's a weird place.
It's settled in at all. Have you seen it since?
No, not yet. But we know roughly where it is from the telemetry we were getting when it was still operating late in that week during November.
What science have we got so far from Rosetta?
We've set the bar for the rest of the mission in terms of what the first inklings of the comet are. It's a very dark object. Even though we see these images, they look quite bright. They're scaled so that you can see the features. It's very dark. It's about 4 or 5% albedo. That's how much light is reflected. That's darker than the asphalt on a road. Right. And we're seeing these jets of activity. This is the gas that we see subsurface. We think there's a hard subsurface layer of ice that's emitting this gas, sublimating, and bringing off a load of dust at the same time. And this is going to continue to get more active as we get towards August this year, perihelion closest approach, and then it's going to really kick off then.
So the surface is this styrofoam density, then you've got ice below. And then we've got, this is another of the images which I found fascinating. It's both the same image, but this one's enhanced.
Yeah, we've enhanced this to show some of the activity that we're seeing. This comet is fantastic. It's got aspects of all comets that we've ever been to before, and we sat there next to it for over a year. So we see these pit regions, and we're trying to work out why they form. And it appears that on the sides of these pits, on the cliff edges, we're seeing a lot of the activity forming there. So immediately we're trying to work out why that's the case. Why is it located? And you can see these fine wisps of activity coming up here. So a bit of gas and a bit of dust being lifted off the surface.
So as you get close to the sun, this could turn into a big...
We don't know. There are theories that some of these are formed by a cap popping off to form the hole, and then it'll eat away and become a much bigger crater-like object, but it's not a crater.
You mentioned you getting closer to the sun, which really raises the big question a lot of people have. Will Philae wake up?
It'll take a bit of energy, so we have to wait a bit longer. It was supposed to go into hibernation, just not hibernate in a ditch where it's laying at the moment. So it's a little bit covered. There's not enough sun at the moment. We wait until maybe May. It'll have better illumination conditions, better temperature conditions. We have to raise the internal temperature as well to make everything warm up a bit better.
So by May you'll know if the lander is able to do some science?
We hope so. We hope to have good contact with it then. We're listening each month.
Well, it's done the science though, hasn't it? It's got
done its
data
first
back.
sequence, yeah.
Thanks, Matt.
No, there have been a handful of missions to comets and asteroids before, but Rosetta is the first to prove it's possible to actually land on one rather than just smash into it or sail past. And really, that single step has paved the way towards a new era of space missions. But it's not just scientists who are setting their sights on the valuable potential of comets and asteroids. Gadgets like your smartphone might have been assembled in China, but many of the raw ingredients arrived here from space. Metals like gold, platinum and palladium were delivered to Earth on asteroids and comets. With some asteroids containing trillions of pounds worth of precious metals, could asteroid mining be the next gold rush? Daniel Faber seems to think so. He runs a company that hopes to mine asteroids for profit. But he doesn't intend to bring anything back to Earth. He wants to enable humans to colonize space. And to do this, he needs the materials from asteroids.
The cost of getting material off Earth at the moment is the biggest impediment to doing things in orbit. It's the reason that we don't have colonies and that there aren't people living in orbit right now. So to have the material that comes off asteroids available then as bulk material that we can use will really change the paradigm of living, of building things, and moving out into space.
But Daniel believes asteroids contain something even more valuable than precious metals: water.
Water is so valuable because we can use water as rocket fuel. Break it into hydrogen and oxygen, and then you can burn it, or you can put it into an electrical system and ionize it and accelerate it. And that way it becomes a propellant to push spacecraft around.
If spacecraft could one day refuel using the water from asteroids, they would be able to travel further and faster, and perhaps lay the foundations for future space colonization. But that's far easier said than done.
That shoot for like 100 RPM or less.
Dr. Chris Zacny is developing tools to try to extract water from asteroids. He already makes the instruments that go onto space-traveling robots like the Mars Curiosity rover. But getting water from a frozen asteroid presents a much bigger challenge. So he's designed a new piece of equipment he hopes will have a chance of success. To show us how it will work, Chris makes his own asteroid using liquid nitrogen.
It's pretty cold. It's probably like close to minus 200 C.
Like a real asteroid, it's much harder than concrete, so the water has to be drilled out. But an ordinary power drill won't quite cut it in outer space. Chris has been designing a lander with a special drill on each of its 8 feet. The idea is that it could drill out material from the asteroid while anchoring itself to the surface.
We have a cutter that cuts through a rock or soil. What you have inside is this icy soil. That's what we want. There's water inside, and we want to extract it.
The friction generated by the drill will heat the ice. Because space is a vacuum, the ice will turn straight to vapor, which will purify it at the same time. Chris uses a vacuum chamber to help mimic some of the conditions of space. Water vapor is soon released from his asteroid, and the ice helps it condense into a liquid.
I put a ping pong ball so we can see how much water we have. This water, it's ultra pure water, ready to drink. So cheers. Delicious.
For Chris, that means it's ready to turn into rocket fuel. The idea of mining asteroids to enable humans to survive in space might feel like a distant dream, but several scientific missions are planned to explore the possibility. And entrepreneurs like Daniel remain hopeful that exploiting the resources of asteroids could open up a whole new era in space colonization. We're back here with Dr. Buzz Aldrin. So, in this new era of space exploration, you believe our first priority should be to get to Mars.
I certainly do. There are a few things we need to carry out that'll help us get to Mars and help other nations get to the moon and do things there, go to asteroids. Might even throw in a flyby of Venus, just to check out things. Getting ready to land the exploration modules on the surface of Mars when somebody picks an appropriate site, and then we can move these close together over about a 5-year period until they're fairly close. We can't really do precision things from the Earth, but we can get them fairly close. So then we'll have the cyclers operating.
So this will be robotic missions first to prepare essentially a Mars base.
Yes.
We've got some imagery actually of
Well, it'll be very similar to what we would be bringing together at the moon. The same essential habitats would be interconnected, maybe a little different than what you have here, but we're all learning and experimenting with different configurations.
So, and why? I know the answer. I want to go there. But why would we go to Mars? If you're going to sell this to the American public, the British public, politicians, why?
Well, because it has been the ultimate objective for about 4, 5, 6 presidents since we went to the moon. But we've never reached that point of coming up with a plan, a time, and a commitment to do that. But I think we're really ready to do that.
You know, if a new Kennedy came along and said, before this decade is out, let's say in 2020, so before this decade is out, we choose to go to Mars, could it be done?
Well, I'm hoping that they'll choose the 50th anniversary of our reaching the moon, July 2019, and then it's 2 decades.
So to make that
for American-led international permanence on Mars.
And it's a long trip, isn't it? I mean, it's in any conceivable, it's 2 years in space. So you spent 7 days in space. So could you imagine doing that trip? What kind of astronaut would it take to take a 2-year trip?
It's going to take a very dedicated person, because I am convinced that when we get to the point of making this commitment, we will have realized that we're going there to settle. And that means to permanently stay. And that means we'll prepare the facilities on the ground to be able to last for the first several crews. Then we'll be building that. But the first crew will make a landing and they'll stay there.
And is your plan to create a cycler that would travel from Earth to Mars and back again?
Yes, we've been looking that over for quite a while. I first discovered the simple cycler in 1985. And it's been improved to a dual synodic period every other 26 months. So you have 2 cyclers.
And this would run like a bus service, although a very, very impressive one, that would loop around from Mars to Earth and Earth to Mars.
Yes, and as it does this, it swings by the Earth and goes out to Mars, and then it comes back and goes out. Then it comes back and swings by the Earth, and for a year and a half, it's close by the Earth, and then it swings by again.
Could I ask you, when Apollo 11, so you flew on Apollo 11, at the end of the Apollo program, did you think that you would be part of the Mars program? Did the idea, you know, I know Von Braun had plans to go to Mars with Saturn V technology.
Well, I was not really into thinking about, I was interested in orbits that could go back and forth between the Earth and the moon. As the moon comes around, it could make a swing by once a month. But NASA wasn't interested in what's good for tourists, to look at the backside and the front side of the moon. So it was suggested by a former administrator at NASA when we went to the moon. He said, why don't you look at Mars? So I started looking at Mars in 1985. I came up with this simple first version of a cycler. It's more improved now, much better characteristics, but we need 2 cyclers, and we do it every other opportunity at 26
Now,
months.
we want to talk more about this if we can on Back to Earth after this. An hour after this program finishes, you'll be joining us for more discussion, because I think there's so much more to learn about these plans you have for Mars. Thank you very much.
Yeah, thanks for now.
Dr. Aldrin. As well as sending us your questions, you've been sending in your pictures.
Yeah, we've got this one. This is from a Scouse Smurf taken on March 18th. It's Jupiter, and 3 of the Galilean satellites.
And with news of another astronomical treat for you to seek out in the night sky, let's go back out to Lucy.
Thank you, Dara. Now, I am very excited to be able to show you this fuzzy patch. What you're seeing here is a comet. And not only that, but it is a live view of the comet that's in the sky right now, just to the left of due north and about 45 degrees up, so halfway up the sky. But what's the best way to view comets? Well, a few weeks ago, I went to find out how we can view these fleeting wonders of the solar system. It's a cold winter's evening in Cambridge, and while most people are curled up on their sofas, I'm braving the elements to meet up with one of the country's top comet hunters.
Hello, nice to meet you.
Jonathan Shanklin spends hours in his back garden scanning the skies for new and repeat visitors from the outer solar system.
Fantastic skies you've got here for a city centre location.
Considering where we are, it really is amazing.
For the last few months, he's had one particular comet in his sights.
What we're seeing this evening is called Comet Lovejoy. Now, comets are named, or often named, after the person that discovered them. And this one was discovered by an Australian amateur astronomer called Terry Lovejoy, and it was found back last August. And when it was first found, nobody thought it was going to be anything terribly special, but it brightened much more rapidly than expected.
Some comets shine so brilliantly they can be seen in daylight, but to view most you'll need assistance, especially in a city location. We're using binoculars, and we've turned off any nearby lights and are filming with a special low-light camera.
So I'm starting at the star.
Yeah.
There are plenty of free guides on the web that will help you find a comet. But as Jonathan has been watching Lovejoy for months, he knows exactly where to look.
I've got it.
You got it.
I've got it.
Hooray.
Wow. It's not a pinpoint of light like a star, but it's sort of
Spread out.
spread out, fuzzy. It is quite faint, but then we're looking at something that's over 100 million miles from us.
Material that's 4.5 billion years old, and you can see it with a simple pair of binoculars.
It can be a little tricky to find a comet at first, as it will appear fainter than many of the stars.
But if you take a photo, it will be much easier to spot. What you need is a digital camera with a decent lens on it, a tripod, and ideally a remote shutter control to reduce camera shake. Then you need to set your ISO to a high value, open up the aperture to let lots of light into the camera, set your focus to infinity, and then use an exposure time of several seconds. Now, all you need to do is point the camera towards the comet and start clicking.
In the image we captured, Lovejoy really comes to life.
The photo shows that the comet is actually a stunning green colour. This is being caused by the gas around the comet fluorescing in the sun's light. It's actually very beautiful.
Amateur astronomers have taken some incredible images of Lovejoy. To get more detailed views like these does require more sophisticated kits. But they reveal Comet Lovejoy's impressive tail of gas and dust lifting off in the heat of the blazing sun. It's impossible to predict when a comet will be first visible, so the work carried out by dedicated amateur comet hunters like Jonathan is vital.
It's getting a bit lower now, isn't it?
Once a comet is spotted, astronomers can then plot its path around the sun to calculate its orbit and forecast when it will next be visible.
Lovejoy last flew through the solar system a whopping 11,500 years ago. Now, it's visible for a few more months, but once it's gone, it won't come back for 8,000 years. So, like many comets, seeing it really is a once-in-a-lifetime opportunity. Comet Lovejoy is still visible in our skies, but only just. You can see it in the bottom left of the constellation of Cassiopeia, but it's so far away now that you'll need a good pair of binoculars and a tripod to be able to see it. But don't worry, for the comet lovers out there, there is another exciting object to be seen later this year, and that's Comet 67P Churyumov-Gerasimenko, none other than the comet that Matt and the Rosetta team are studying in exhilarating detail at the moment. Now, this comet will be back in our skies after a 6.5-year absence, but you'll need a good pair of binoculars to see it. Go out and look just before dawn in the eastern sky between the constellations of Gemini and Cancer.
Lovely, well done, Lucy, and correctly pronounced the name of 67P, which I chickened out of doing earlier on. Now, a quick catch-up on that challenge we set you last night to find exploding stars, supernovae. With exciting news, here's Chris Lintott.
It is exciting. You showed the image that we found earlier, which was selected by our volunteers from the hundreds of thousands that we had online. This is a star in our own galaxy, but next to it, this is the supernova. And what I find remarkable is this is in this distant galaxy, and it's as bright as a star that's in our own system, which is rather fun.
Core, as we said.
Yeah, no, what we did with this was we got this pretty quickly, just after the show went live, and so we passed it to our friends in Chile, who were using this thing. This is the new technology telescope. They were able to measure the distance to this thing, and so the supernova is 500 million light years away.
I think that's wonderful, isn't it? 500 million years travel time. So the Cambrian explosion had just happened on the Earth. The first multicellular creatures hadn't yet crawled out of the oceans. That happened.
And then we arrived in the last couple of days, just in time for this show.
Stargazing 2015.
Do you think it was planned in some way?
No.
I don't either.
But on the other hand, we would have missed this if it hadn't been for our volunteers. We're still arguing over what type of supernova it is, but we've also got new data from our telescopes in Australia, which has been taken just in the last 12 hours.
So we're taking new data from Australia, bringing it here, throwing it out to the viewers here. They process it. It goes to Chile tonight.
In about a couple of hours, with any luck. Yeah. So what we need people to do is to get onto the website, snapshotsupernova.org, or via the Stargazing website right now, at least in the next couple of hours, so that we can identify targets. If we found this last night, who knows what will be in there for the rest of the night.
I should say, actually, behind the scenes at Stargazing, so we're in the bar, just having one drink each, as we do, and Chris came running over his laptop and goes, we go on. So that was you finding it. So that was about 10:30, 11 o'clock, wasn't it? So it's absolutely...
There were two guys who were on a corporate thing who looked at me and said, I wish I had his job.
And then he was running around going, I'm ringing Chile now. And so he did actually phone that telescope.
OK, but that's not the only challenge you want people to get involved with. This is a really interesting experiment you want to do now.
Yes, this is more experimental. This is, we want to take a nice nice wide field image of the sky, of the constellation of Orion, but one which shows the kind of detail that you normally only see using a telescope. And we're not going to do that with fancy equipment. We want people at home to help us do that. So if we take an ordinary image of Orion, taken with the kind of camera that you might have on the shelf, this is just a digital camera.
There's Betelgeuse up there.
There's Orion. So that's one such image. There are loads of these. Somebody else might go out and take an image like this.
Even a camera phone would work for this?
I hope so, yeah. We should definitely try that. Whatever you can get your hands on, go and take a picture of Orion. And then if we add them up, and this is an image with only 6 of those images, you suddenly see all these other stars, all this other detail, all this faint stuff that was otherwise hidden. We've got this new way of combining images, and we want to see what happens if we take thousands of images of the same piece of sky and put them together.
And we're interested in these regions, so this
is the star-forming region down here, and this whole area is covered in gas and all sorts of things that are going on that we'd like to be able to see.
So people can do this with any camera?
We think so.
How did they get the pictures to you?
There's instructions on the Stargazing Live website, but basically go to our photo sharing site and use the hashtag Orion. Our software will recognise where it is in the sky, stick those images together, and we'll present the best image of Orion you've ever seen tomorrow night's programme.
It's great, Chris. I just want to remind everyone, the supernova, we're trying to recalculate the age of the universe. That's what that data's for.
But we need supernovae of the right type, and we're not sure we've got
one. So the one we've got might not be of the right type. We need more.
So more help needed. Now, as well, if you want to contribute to the best photo of Orion ever taken, please go online. Tomorrow we're going to reveal the picture you've all created, and we'll put it up on the website so you can download it. And remember, your picture will be in there somewhere. Well, of course, the first thing you need to, if you want to join in with that one, is find the constellation of Orion. So for a quick reminder of how to do that, let's pop back over to Lucy out in the dark field.
So, presuming you have clear skies, unfortunately it's just started to cloud up here, you need to look towards the west to find Orion, and it's dropping down towards the horizon, so don't hang around. It sets around 10:15. If you want to pop out tomorrow night, then look after sunset, but look towards the southwest, and Orion will be halfway up the sky. But actually don't worry if it is getting late and the constellation is dropping below the horizon, because we still want your photos. As long as you can see Orion's belt and that bright red star in the top left, Betelgeuse, still take your photos and send them in to us. Now, don't have a late night tonight because we've got an early start tomorrow for the solar eclipse. I'll be in Leicester along with hundreds of others who are excited to see it, and hopefully I'll see you there.
Now, it's less than 12 hours before we'll have a chance to see the very latest solar eclipse. Just to whet your appetite, this is what an eclipse looks like from space.
Yeah, this is the first photograph from the Mir space station in 1999. So this is the eclipse I tried to see in Cornwall, and it was cloudy. But I think it looks, that's the shadow of the moon over Britain. It looks very sinister to me.
It does actually, yeah. But you can see both the shadow of the moon and the cloud. And in a moment, we'll be going back to Liz and the fair ones one last time. But first, the question we're all wondering about, that our fingers are crossed on: what's the weather going to be like tomorrow?
Good evening. Well, we've got high pressure across the UK, keeping things generally settled and dry, but certainly mixed fortunes in terms of cloud amounts and any clearer skies. Generally, there is quite a bit of cloud out there tonight. The clearest zone will be through parts of Lincolnshire, the Midlands, through southern Wales, towards parts of southwest England as well. That's not to be said that there won't be some clearer intervals elsewhere, but generally fairly cloudy across southern areas, and with an approaching weather front in the north, increasingly cloudy here, with some hill fog and a few spots of drizzly rain. So if you're hoping to view the eclipse tomorrow, well, we could see 85% of the eclipse towards parts of the southwest of England, particularly for northern parts of Devon. Many southern counties of England fairly cloudy and grey, but really through this central zone, the Midlands, Wales towards Lincolnshire is your best bet for viewing the eclipse. Northern Ireland, Northern England and southern Scotland, mainly grey. There could be some brightness across the east of Scotland and up towards the Faroe Isles. Well, it'll be hit and miss. Some sunny spells, also a few showers rattling by as well. So for the rest of the overnight period, it's looking fairly cloudy. Some clearer spells, though, tomorrow.
OK, so mixed news across the country there, but don't worry if it's going to be cloudy where you are, because Liz Bonin is on a mission to guarantee you the best view in the world live from the Faroe Islands. Hello, Liz.
I am on a mission, and as you've just heard, it's hit and miss tomorrow on the ground in the Faroes. It's been really bad today, actually. Lots of thick fog, lots of rain, but there's supposed to be clearer skies for a window of about 5 hours tomorrow morning. Cloud cover shouldn't be a problem for us, as Dara just said, because we're taking to the skies 25,000 feet up there to try and get you the best possible views of the solar eclipse as it happens live. We've kitted out our very lovely Stargazing live plane with specialist cameras. We've got 2 solar telescope cameras, solar filtered, I should say, different exposures, different frame sizes. We've got a wide-angle lens trained on the sky as totality happens and we're plunged into darkness, and one very special filter to give us a different view of the sun. That's really, really stunning. BBC One's Chris Hollins will be up in that school on the hill enjoying all the excitement. I'm heading back to Jodrell tomorrow night to show you exclusive pictures I'm keeping just for you, but we will see you tomorrow morning, BBC One, 9 a.m. Fingers crossed, everyone. See you soon.
If there's anything you want to ask any of the team tomorrow, send us your questions now. And we'll be back tomorrow morning.
Oh yeah, 9 a.m. on BBC One to share the whole eclipse experience with you moment by moment. And a quick reminder, the eclipse starts at 8:18 in the southwest, which you can see on BBC Breakfast.
You can also follow, by the way, it's streaming live on the BBC Eclipse. So there's loads of things you can see. Don't forget that we're back in an hour as well with Back to Earth. We'll be meeting more, chat with Buzz, and finding about missions to Mars and if you've got what it takes. But now, a period drama on BBC Two, just for a gear change before you see us in another hour.
See you later.
Enjoy.